Okay, in our last section that we have in this chapter, we're going to kind of do the reverse of everything. We're going to be given a graph, and you're going to have to write the equation of the inequality. So let's take a look at your notes as we kind of go through this here. So today what we're going to do is first we're going to be given a graph, and the easiest way to do this is to first identify your y-intercept, or another way to think about it is that's your b value, where the line hits the y-axis. Just kind of remember yourself. So we first want to pick out our b value. From there, we want to pick another, what I call a friendly point, or another nice point, and you want to determine your slopes. You want to determine that m value, or your rise over run. Because if you can identify your m and your b, then you can put it into y equals mx plus b, or what we call slope-intercept form, which is your y equals mx plus b. Now, the only thing that's going to be kind of difficult is once we get to inequality signs where we have the greater than or less than with the shading. And we'll kind of talk about an easy way to determine what the symbol is on that. So let's some examples here. So looking at your notes here, what I first want to do is we're going to start with an inequality one. So to do this, what we want to first do is pick out your m and your b. So I'm going to put m and b, and let's pick these out. So the nice thing to do is to pick out your b value. So I'm going to go ahead and plot my b value right there. So I know my first b is 4. So how do I move from 4? So I want to pick out another nice point, and it looks like all of these are hitting really, really nice right here. So I want to use my rise over run. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Since I go up, it's going to be positive. Since I go right, it's going to be positive. So it would be 1 over 1, which also equals simply just 1. So if I want to write my y equals mx plus b, it would be y equals 1x plus 4. But the problem is this: we have an inequality sign. So I'm going to write this statement here, y, and I'm not going to use an equal sign because I know that I have shading going on, is 1x plus 4. So what we want to do is we want to determine if it is a greater than, less than, greater than or equal to, or less than or equal to. Well, the first thing I see is that this is a dotted line. So I know it's not an equal to. So I know it's not less than or equal to or greater than or equal to. I know it is a greater than or less than sign. So how are you going to figure this out? The easiest way is to pick a point in the shaded region. So let's look at a nice point in the shaded region. So I'm going to come up here, and I'm just going to simply pick, that would be, 5, 6, 7, 8. So this point is 8, 0. So since it is in the shaded region, we want a statement that is true. Okay, so if I plug in my value, so we know that this is x and this is y. So I'm going to plug in my value, 0, some symbol that we do not know, 1 times, and I'm going to plug in my next one, 8 plus 4. So this simplifies down to 0, some symbol, 12. Now, we want this to be a true statement because it's in the shaded region. So what would make the statement true? Well, we'd have to use a less than sign. So we come up here, that makes my statement, and we're done. Okay, let's look at another example here. So what I want you to do right now is I want you to pick out your m and your b value. So pause the video for a second, pick out your m and your b values. Okay, so what you should have found is this: your b value is -1. Now, what did you find your slope to be? Okay, so we want to find another nice point. It looks like it hits at 1, 1. So if I want to count my rise over run, I would go up 2 over 1. Notice that it is an uphill line, so it should be a positive slope. So it's 2 over 1, or 2. So once again, we know we have an inequality, so we write our statement, y, some symbol, 2x minus 1. So what's that some symbol going to be? Well, let's pick a point that we can plug in that's from the shaded region. Once again, I want to pick a nice value. I always pick a positive value. I'm going to pick this point right here. And it doesn't really matter what point you pick as long as that point's in the shaded region. So that point is 5, 0. So your x is 5 and your y is 0. So let's plug in our values. Since it's in the shaded region, we want it to be a true statement. So we plug in 0, some symbol, 2 times 5 minus 1. 0, some symbol, 9. Now, what would make that statement true? Well, 0 is less than 9. Now, why do we not use equal to? Because you have a dotted line again. So since it's dotted, we don't use it, and we come up here and we throw that in there, and you're done. Okay, flipping it over. This one's just a little bit different because look at how my line is going. I notice it's going downhill. The way I like to think about it is if I'm driving here, it's going downhill. So that kind of tells me that I know that I'm going to need a negative slope. So keep that in the back of your mind as we kind of do this. The other thing is notice that this is a solid line. Okay, that's gigantic when it comes to making your symbol greater than, equal to, less than or equal to. Okay, so we know it's going to be an equal to symbol. So once again, same idea, same thing. Pick out your M, pick out your B, and let's fill in those. So on your own, what I want you to do is pick out your M and your B, and we'll talk. Okay, let's take a look at this together. So if I highlight my value here, looks like it hits at positive 3. Now this one's kind of interesting because it's going downhill. So I find another nice point, which is right there, and you could pick any point. Now this time I'm going to fall and then run, okay? Since I fall 1, 2, 3, 4. So I fell 4 and then I ran 2. So it's negative 4 over 2, which is simply M equals negative 2. So we have a M and my B. And it should be negative because, like I said before, it's downhill line like we would drive. So we write our statement, y, some symbol, negative 2x plus 3. So how do we determine what symbol? Same idea as last time. Pick a nice value within the shaded region. I'm going to stick with what I had here. I found 5, 0. So here's my point, 5, 0. That's x and that's y. Plug in my values. 0, some symbol, negative 2 times 5 plus 3. So let's simplify this and see if we can make this true. So 0, some symbol. This would be negative 10 plus 3 would be negative 7. So what would that make that statement true? So this time it's going to be greater than or equal to. Why is it equal to? Because this right here is solid. So since it is solid, it's greater than or equal to, makes that statement true. And we're completed. Okay, this time, why don't you go ahead and pause the video for a second, see if you can do this one completely by yourself, and then hit start, and I'll go through it with you again. Okay, so hopefully you've had some time to stop and try this on your own. So once again, same thing. We pick out my M and my B. So let's look at my B value first. It looks like it is at negative 4. And it looks like another nice point is at 2, negative 3. Notice how I always pick my point to my left first and then to my right second. That way I can rise and run. This one's kind of an interesting one. So it looks like I rise 1 and run 2 actually. So it's up 1 over 2 with the B value of negative 4. So we're going to write my statement, y, some symbol, because we're using the shading here, 1/2 x minus 4. So what point are we going to pick? We can't pick 5, 0. We can't pick 0, 0 because none of them are in the shaded region. We want to pick something that's in the shaded region. And I'm just going to come down here and use a nice easy point of negative 6, 0. And we're going to plug in our values. Just remember that this is x and this is y. So let's plug our values in now that we know what is x and what is y. So this time is 0, some symbol, 1/2 times negative 6 minus 4. So negative 6 times 1 is negative 6, divided by 2 is negative 3 minus 4. So that would be negative 7. That was what that would come to. Some symbol, 0. So once again, we want to put a statement in here that is true. 0 is greater than or equal to, since we have a solid line. And that is a true statement, so we want to put that statement in right there, and you're complete. So hopefully that answers your questions about how to find it. The only thing that we really didn't talk about in terms of this is what if we didn't have the shading? Then you wouldn't have to worry about the whole greater than or equal to, and you can just put an equal to sign in between the statement right here. You can just put an equal to sign. So we went over the more difficult ones. This should give you enough information for your homework. The last thing we need to look at, though, is good old word problems and how we're going to apply this, because you're definitely going to see these on your review and on your test. Okay, take a second and go ahead and read through this problem, and we'll kind of discuss how you can take what we know so far and apply it to this real-life application problem. Okay, after giving you a second to kind of read through these and kind of figure out, so what we have this girl that's working 2 part-time jobs, and it says that she wants to make at least $240. So I'm going to go ahead and write some things down. She wants to make $245 in a week, and at job number 1, she makes $10 per hour, and at job number 2, it says she makes $15 per hour. Okay, so since we know this stuff, PER, we talked a lot about this in the last chapter. Okay, PER is a big one. PER is the multiplication one. Okay, now the thing is that's kind of tough is we don't know how many hours she's working at each. So it's kind of 2 unknowns this time. Instead of last chapter, we said 1 unknown. So what we want to do, since we have 2 unknowns, we're going to put X by job number 1 and Y by job number 2. So what that would say is I know 10 times X, because how many hours I work at job number 1, plus 15 times Y, how many hours I work at job number 2. That money, that has to be greater than or equal to 240. Why greater than or equal to? Because it says at least 240 per week. She can make more than 240, but it has to be equal to 240 or greater. So now what we would do is we would take this statement and we would put it into y equals mx plus b. So we start off by subtracting 10x over. So you get 15y is greater than or equal to negative 10x plus 240. Next, divide by 15, applying everything that we learned. So finally, the equation that would represent, or the inequality that would represent this whole statement is y is greater than or equal to negative 2/3 x plus 16. So what we would do is we could graph this, shade it in, look at our shaded region, and that region that is shaded would represent all of the possibilities of the number of hours she could work at each job in order to get $240 a week, because there's a million different combinations that would work to at least get $240 per week. Okay, let's look at one more of these. Like I said, you'll see these on your test and on your review, so let's make sure we kind of understand what's going on here. All right, so on this one here, give you a second here, go ahead and read it to yourself. See if you can set up the inequality, and then we'll talk. Okay, after giving you the time to kind of read through this here, let's take a look at this example here. All right, so on this particular one, what you have going on is that Hugh works 2 part-time jobs. So we got job 1, job 2. Let's see what we know about each job. It says that job 1 at the grocery store pays $10 per hour. And then it says babysitting pays $13 per hour. It says how many hours do they have to work to earn at least $260? Well, same idea, same thing. We got 2 unknowns, so this time we have to use 2 different variables. We'll make job 1 x and job 2 y. So once again, it's per hour, so we use multiplication, so 10x plus 13y, and it says she wants to make at least $260, so it would be greater than or equal to 260. So now, if we want to graph this guy, we would have to put it into y equals mx plus b. So we start doing the same exact steps. Subtract over 10x, subtract over 10x. We get 13y is greater than or equal to negative 10x plus 260. And finally, we divide by 13 and divide by 13. And so your final result, the inequality that would represent this if we wanted to graph this, would be y is greater than or equal to negative 10 over 13x plus 20. So once again, we could graph it, we could take a look at it, and then shade it, and we're going to go from there. So now that you kind of have the idea from here, continue on with the Nearpod, answer a few questions, and see how you guys did on this, and then the substitute will have the homework for you guys.